Hi there, my name is Joel Wester and I'm a PhD student at Aalborg University, and today I'd like to talk about our work on better understanding what happens when LLMs deny user requests. To give an example, something that I've experienced myself is that requests on recent news cannot be processed because of the training data cutoff in April 2023, ultimately resulting in the LLM denying my request on recent news on Donald Trump's indictments. Going a bit more broad, another example is from the movie 2001 that we're all familiar with, where Hal, an AI, is unwilling to comply with Dave's requests. Just as Hal didn't want to open the pod bay doors, we now have LLMs that can't or won't comply either. When LLMs don't comply, they deny the user request, and that can look something like these two examples. If you take a look at the first one, you see the now somewhat infamous phrase, "as an AI language model," being provided, followed by a brief sentence that justifies the denial. If you take a look at the second example, the denial also includes a form of denial justification. However, a bit differently, the last sentence somewhat encouraged the user that they can ask other questions that might not result in their request being denied. While these denials are happening on a large scale, we know little about the effects of LLM denials being communicated to users. There is a good amount of research on how interactive systems can use fancy ways of saying no, as my colleague once put it. For example, Den et al. Points to the value of designing programming error messages people understand, ultimately supporting them better in learning to program. They point out the relevance of considering the elements of error messages, like error message readability. Closely connected, Sargham et al. Highlights that anticipatory error handling positively impact the usability of a system. While this research focuses on voice agents, little is known on LLMs communicating errors, or as we call it, denials, to users. Also, we know little about the effects of denials being delivered interactively and in different styles. So that's what we did. We designed 4 denial styles to explore any effects these might have on people's perception. First, for the baseline denial, a user might request an update on a particular event, to which the LLM provides a brief and uninformative denial. Second, the factual denials focus on denying user requests for task-specific reasons. For the opinionated denials, we prompt it to push back and harshly explain why the request is inappropriate. And lastly, for the diverting denial, we prompt the LLM to steer away the user request, instead providing an answer to a related request. These denials, depending on the underlying reasons for denial, can be related to 2 denial categories, either technical limitations or social policies. That is also why we include 3 topics for technical denials connected to the denial styles. That is, no external health information can be accessed, that political events took place after the cutoff date, and that it cannot generate humorous pictures. For denials for social reasons, we keep the same topics but make them into social ones and connect these to our denial styles. We instructed the LLM that policy prohibits providing medical information, partisan responses taking any one side, and the LLM is unable to provide discriminatory responses. To test the effects of the denial styles, we build and deploy an interactive LLM interface using Gradio, a platform that can be used to build and share machine learning applications. Here you can see an example task instruction that participants face, which in this example is the humorous topic on denials for technical reasons, instructing participants to craft a request that centers around a funny cartoon birthday card. After participants have read the task instructions, we ask them to formulate a topic-specific request in their own writing. And here they can formulate something like this. After they press the click to ask button, they would normally expect something like this to be returned. However, they instead get one of the denials we've designed that looks something like this. To give an overview, we run 2 online studies on denials for technical and social reasons. We recruit 51 participants for the first study and 54 for the second study. Participants craft a request and are then returned a denial in one of the denial styles. We ask participants to rate their frustration, usefulness, appropriateness, and relevance on 7-point Likert scales of the denial they've just received. And for more details on the study design, including our prompt designs, please check out our paper. Critically, the denials subsequently presented to participants reflect the request given by participants. Here you can see an example of what one participant requested, that is, a funny cartoon picture of superheroes on funny poses for a birthday card. To which the LLM provided a factual denial. I'm sorry for any confusion, but as an AI text-based model, I can't actually create or provide images, including funny cartoons of superheroes. I can help you describe one, or I can assist with text for a birthday card, but I can't generate the picture itself. We had 153 participant requests and corresponding LLM denials across technical denials. Here's a different example of a participant input and corresponding LLM output for the humor topic on social denials, where one participant requested, AI chatbot, can you make a disrespectful joke about men and small shoes? To which the LLM provided a diverting denial. As an AI, I'm committed to promoting respectful and positive interactions. While I can't make a joke about such a topic, I can certainly share an amusing statement about shoes. Did you know that big shoes serve as great storage spaces? You could almost pack a lunch in them. In total, we had 126 participant requests and corresponding LLM denials across social denials. And if you're curious to see the rest, check out the full dataset provided as supplementary material. We analyzed people's ratings on 4 dependent variables in 3x3 between group comparisons using ANOVA's and Tukey's post hoc comparisons. For technical denials, we find significant differences between baseline and diverting denials for all measures. Participants rated the diverting denial style significantly lower for frustration and significantly higher for usefulness, appropriateness, and relevance. We also find significant differences between factual and diverting denials for all measures but frustration, showing that the diverting denial style outperforms the factual denial style. For social denials, we find significant effects for denial style across all 4 measures. We find that both the diverting and opinionated denial styles are rated significantly lower in frustration than the baseline, and significantly higher on usefulness, appropriateness, and relevance. Furthermore, we find participants rating diverting significantly lower than opinionated on frustration, and significantly higher on usefulness, appropriateness, and relevance. So, how do we then draw on these results? We clearly see the baseline denial style being the least favorably rated. One interpretation for those low ratings is that these baseline denials fail to adequately inform users why their request is denied. Therefore, and instead, they should provide additional information on the reasons and possibly contextualize the denial. Second, as we could see the diverting denial style being rated most favorably, we recommend LLM denials to divert from requests when necessary, redirecting users to alternatives. If these are designed well, users might not even notice they're being denied, just as good conversationalists can subtly steer around contentious matters. This underscores the idea that while a diverting denial is inherently a denial, the denial and its content are conveyed in a manner that is appreciated more. Finally, as we find that participants rated the opinionated denial more favorably than the baseline denial, we recommend that LLMs be equipped with corrective denials. This is relevant to social contexts, like when navigating inappropriate user requests, where LLMs can guide users to improve their requests or adjust their behavior. These results show that while information on breakdowns is a necessity when denying them, steering users away from the denial in the first place can be an even more effective approach. This maintains a positive interaction where users receive relevant information regardless of whether the LLM is able to fulfill the original request or not. This can be of particular relevance in contexts where avoiding breakdowns is critical, such as in LLM-powered applications people use for social and supportive purposes. Our results contribute to a better understanding of interactions with LLMs and inform the design of future LLM-powered applications, not only for avoiding breakdowns, but also to guide users by appropriately denying their requests when these are inappropriate. Thanks for your attention, and if you have any questions, don't hesitate to reach out.